Hello everyone, this video is about MATLAB based implementation for face emotion recognition. At the end of this video, we will show you how to implement line by line code for this live webcam demo in which a deep learning architecture first detects a face and then based on facial features, it identifies either a person is, for example, sad or angry, or for example, if a person is happy or any other facial expressions correspondingly. If you have just visited our video for the first time, I would like to inform you that in our channel, we do have 4 different videos for the same topic such as face emotion recognition. My name is Shanullah and I'm a PhD student at Inha University, South Korea. My major is computer vision and deep learning. Let's get started. Before diving into implementation, let me introduce briefly all 4 videos, like the scope of all 4 videos, such as if you are at the beginner level and you do not want to train everything from scratch and you hesitate to train, I would like to recommend you deep face. On the other hand, for example, if you do have a little basic knowledge of deep learning architectures and you are interested to follow your career in any of them like TensorFlow, PyTorch or MATLAB, you can follow any of them. This particular video is about MATLAB based implementation. In all 3 videos, or definitely the 4th video as well, we would definitely explain the concept. One extra information I would like to give you is that the input and the output for all these 4 videos is same, while the methodology is different. This is the outline of this video, such as initially I will just explain the concept, then dataset, and then I would like to inform you what is transfer learning and installation requirements and all other things such as code implementation. If you already know the concept, you can just skip any of the section and directly dive into the code implementation. Broadly speaking, the facial expressions can be found by 2 different methods. One is camera based technique and another one is physiological based technique, or also known as biosignals. So the camera based techniques, for example, if I take an image, the front looking image of a guy or a girl, and then if I detect a face and then I trained these faces to my deep learning architecture, at the end of the day or after training, this model can classify any of the expressions correspondingly. In this particular case, this deep learning architecture has, for example, classified this face as an angry girl, right? So we can also classify into happy, sad or surprised based on the facial features. In this case, we do not know that the girl is what is the intensity of the angriness. She looks angry, but this could be fake up, right? She could be fakely angry, as in the start I show you my video and I was just faking up to make my facial features so that deep learning architecture can detect my face correspondingly, the facial expressions correspondingly. So in this case, we do know that this girl is angry, but we do not know that what is the level of being angry. In this scenario, biosignal is the best solution. For example, let me connect this. Okay, using the biosignals, we can also identify the intensity level of the angriness. And once we divide further the level of the angriness, this is called as regression problem. So for example, if a person is angry and we call it 1, so the level, for example, 0.1 and the lowest level is 0.1, and for example the highest level is 0.9 or 1. So in this case, for example, if the deep learning architecture based on the biosignal, it identifies for example it outputs 0.1, it means that we have a low level angriness. Similarly, if it says that it is 0.9, it means that high level of angriness, and then it can be converted into tense and excited and all other different categories. So one thing we have established so far, that The difference between classification and regression is that the output of the regression is always in the floating point, while the classification output is always a decimal number. So now that we have established the difference between them, so one another additional knowledge I would like to inform you is that in the case of biosignal, we always need to connect a sensor to a body. In this particular case, this is an EEG based sensor, and has been connected with a person. So in order to detect, for example, if you want to get the biosignal, we have to connect this sensor to this girl. So this is, for example, EEG based, like brain signal based. Definitely we can detect the cardio based and respiratory system based, and different techniques. We do have biosignals in which we can say that what is the human emotions. So for the biosignal, we call it human emotions recognition, right? Not the facial expressions. So this is the difference, right? So the computer vision technique is facial expressions based because we can identify the expressions, while in case of the biosignals, we do have human emotions recognition. So in this case, we just detect, for example, EEG signals. This is a typical 32 based signal, and then we can train this signal into a deep learning architecture, and then it can classify or can output the regression. Sometimes we can treat regression as a classification. How? For example, if I'm getting any value from 0.1 to 0.9, I can just say that I can just deploy an if else statement that this is always angry. So regression can also be treated as a classification problem. So this is the scope of our video, today's video. And if you want to learn, for example, if you are also interested in biosignals, please do let us know via your comments, so that we can also create or make a video in future based on biosignal techniques. Now that we have established that our technique is the classification problem, so based on facial features, this girl is angry, this is disgusting, and this, for example, fear, happy, sad, surprised, and neutral. So in this case, based on these facial expressions, we cannot detect or identify that which kind of facial expressions it is. So we classify it as a neutral. So in total, we are just, for this particular video, we are classifying into 7. Although we do have tensed and excited and many others as we showed you just before. So out of a lot of available datasets, we have selected this FER 2013 dataset, Face Expressions Recognition. It was published by Google in 2013, and there were 3 in total datasets, but one of them were FER 2013, and it is published in Kaggle website. So Kaggle is those who do not know about the Kaggle is a website actually, and across the globe, when there is a company, for example, a company has some problem, right? So the best way is that they introduce this problem to a Kaggle website, and on the Kaggle website there is a competition launched, and all over the world the deep learning experts just resolve this problem and provide their solutions correspondingly, and then later Kaggle website just announce the results, right? Who is first, who is second, and correspondingly. So I just want to let you know that if you are deep learning enthusiast and you want to do something really good in deep learning, you should go for the Kaggle competitions. Okay, so now coming back to our topic, why we selected the FER 2013? Because it is a realistic dataset. By realistic, what do I mean? By realistic, I mean that, for example, in this case, these pictures are very much clear, like background is white and this expression is very crystal clear, right? But in real world scenario, for example, if we train our deep learning architecture on these front faces, then if we deploy in the real world, definitely our deep learning architecture would fail. Why? Because in the real world, we do not have always a front looking face, right? So that is why this FER 2013 is a realistic dataset. How they get a realistic dataset? Because it is by Google, as I told you before. So in the Google database, what they did is they just search all different videos, images in all inside the Google database, and they just crop all the images. So these images, you see, there are some watermarks as well. These are some watermarks as well. So they are actually real world images and videos uploaded by different people in the world, right, on the Google database. So they have this is the realistic data set. Okay, so as it is a realistic data set, so you can notice over here that there is an imbalance problem. Like in the Google database, the videos uploaded by different people, they could only find 436 samples of the discussed. Similarly, for happy, they could find a lot of them, right, such as 7214. So ideally, all of the samples must be same. Why? Because deep learning architecture, for example, in this case, deep learning architecture would be biased towards happy. So the weight of the deep learning architecture would be biased towards happy. So what is the solution of the imbalance problem? Solution is data augmentation. Augmentation means increase. Okay. So data augmentation means increase. So how can we increase this data set? For example, this is discussed. These are only 436 images. So what we can do is that, for example, we can rotate this image and create another image. Similarly, we can scale, like zoom in, zoom out. We can do it. Similarly, we can translate, and a lot of other techniques we can do. And we can create more images so that these images could be same. Another technique is GANs. GANs means generative adversarial neural networks. So as I show you, this Ian Goodfellow is the author of the GANs. Actually, he's a pioneer of GANs. So we can create fictitious faces, such as, for example, not real, but we can join two images into one. We can might have noticed a lot of mobile application who can just create new images, right? So GANs can create new images. So another solution is for data augmentation is GANs. Similarly, we have intra-class variation of FER. So as you can see over here, all of them belongs to angry, but in this case, intra-class variation means that these are black and these are white. Okay, so a lot of variation is this, and similarly, some belongs to painting, some belongs to cartoon, and these are a lot of intra-class variation. Intra-class variation means inside the class we have a lot of variation. So again, this corresponds to a realistic data set, right? So in order to resolve this problem, the deep learning solution should be robust in nature, and one of the solutions to avoid overfitting is to add dropout layer and maximize the max pooling layer and tune the max pooling layer, and a lot of other techniques, which is not the main topic of this video. Similarly, there is a collusion problem. I'm just explaining how much complex this data set is. One of the problem is occlusion. So this guy has just covered his face by his hands, right? So it's very hard to identify the facial expressions. Similarly, we have eyeglass, such as this girl has covered her face with the glasses, and the eyes are her eyes she has covered with the eyeglasses. So it's a very important feature for the facial expressions recognition. Why? Because in this way we can identify that she's surprised, right, or maybe feared. Similarly, as it was a realistic dataset and there were cropped images, so they also have cropped mistakenly like there are outliers as well. So deep learning architecture should be robust enough to tackle all these problems. So today video is about the MATLAB based implementation, right? We will implement in MATLAB. So what is transfer learning? Our methodology will be based on transfer learning. As the name says, transfer learning, it means that we can use our previous knowledge to infer or to conclude a new deep learning architecture solution, right? What does this mean? Let me tell you. For example, any deep learning architecture, okay, we have connection in neural networks, right? So these connections are actually nothing but set of weights. Okay, when we store some deep learning architecture, right? In the model, when we store, so actually these weights have been stored, right? So for example, we have cat and dog problem, right? We want to identify cat and dog, right? And we first, it's always the practice that initially we just randomly initialize our weights and then we train. Okay, this is epochs and this is accuracy. So usually we train our deep learning architecture to, for example, in order to classify cat and dog and many other animals, we can just start from the scratch. Now after being implementing the classification, deep learning architecture classifier, a well-known classifier, for example, it achieves 90% accuracy. Then later on, for example, if someone want to classify lion and elephant, for example, so you can observe that most of the features would be same. For example, 4 legs and different textures would be maybe same, right? So in order to do it, rather than reinventing the wheel, it's better that we should use these weights, not the initial weight, right? Not from the scratch. We can use these weights and just modify only those important places where it should adjust for lion and elephant. This would save our time, right? So in this case, our accuracy will hopefully start from 40 or 50%. Why? Because it don't need to modify all of the weights, rather only few weights inside the neural network. That is called as transfer learning. So for transfer learning, it is very important that the nature of the problem should be same. Like you see, both of them are classification, right? The classification one. So that is why the nature must be same in order to perform the transfer learning. As we are doing face emotion recognition, so previously we have a lot of best classifiers in the world, like MobileNet, it is by Google, similarly GoogleNet, AlexNet, and a lot of them. It was actually, they are being trained on 100,000 classes based on ImageNet dataset. It is 130 GB, a huge dataset of 1000 classes containing a lot of animals, a lot of objects in the world. So they have being trained. So these weights, as I told you before, these weights are already trained by MobileNet, by GoogleNet, and all different architectures are already available. So it's better that rather than doing it from scratch, this solution is better, right? It would save our time. We can come to the conclusion very easily and very fastly. With less epochs, right, we can achieve a good result, and you will witness soon in the video when we will be implementing. Okay, now once we established that what is transfer learning, okay, so the next question is how to do it, how we can resolve the in the programming, what are the steps to follow. For example, the number one step is, as we are treating it as a black box, this weight matrix, like this is a model, we are treating it as a black box. The first thing is input and output must be same. Why? That is how it will adjust its weights. So previously all of them were trained on this. So one of them is AlexNet. It was published in 2012, and it was trained on 227 into 227 2D image, right? However, all rest of them are trained on 224 into 224, right? So one thing is, our image size must be 224 into 224. Our output size, as it was 1000 previously, 1000 objects. In our scenario, it should not be 1000, while we have 7 classes as we have just discussed. So 7 classes, right? Now how to do it? So in this data set we have 48 into 48 size. So we will upscale 48 into 48 into 224 into 224. Okay, now we have input is same, then output we need to modify. Why? Not 1000 classes but only 7 classes. As we know that how we get this 1000 classes, our fully connected layer, the last fully connected layer, as we have seen, it should be always same. The number of neurons should be same, equal to the classes, number of the classes, right? So we will modify the last fully connected layer from 1000 into 7 classes. Okay, so this is our methodology how we can do it. Once we have established how to do it, let's dive into the implementation. And the tools we will be needing is one thing, definitely MATLAB, because we are going to implement inside the MATLAB. And the most important toolbox we will be using, one is deep learning toolbox, okay, for LXNet and all other deep learning architectures. And secondly, in order to get the webcam image, we will do it image acquisition toolbox, right? If you want to do it, for example, if you want to read the image live, if you want to just read the image, you do not need it. But in case you want to deploy a live webcam demo, definitely then you use image acquisition toolbox. For this tutorial, I believe that you already have installed MATLAB. If not, you can just visit Google website and write download MATLAB, and then you can just open this link and you can just download the MATLAB and can install it. And then you can activate it according to your university or any other activations you have. Once I believe that you install MATLAB, you will come up over here, and then you can just click help and the documentation, and you can just write for example, let me zoom it for you. Oh, it's too much zoom. So transfer learning, once you type transfer learning, you can have a lot of examples such as this one. Okay, so this is transfer learning using pre-trained network. This is an example using Google Net, and they have shown you all the steps. So all you need is to just click this open live script and you will be here. So this kind of this example will be open in your editor, and then you can just run it. And then once you run it in a live editor, you can run and everything will happen automatically. Let's study what's going on over here. So there, as I told you in this beginning, that what is transfer learning. In the transfer learning, you can use a trained network, you see, pre-trained networks, to perform classification on new collection of data, as we have already studied this. So as I told you that once you run, it will execute all of these commands inside these commands window, right? So it will just in this step it will download all the data set, and then it will split to 70 or 30. So all description is just given over here, and then it can just train or for training it will read all the images, and then it will load a pre-trained network. Net is equal to Google Net. So now this Google Net is not an ordinary name or a variable, rather it is once you write, it will download from deep learning toolbox, right? And then you can check deep network designer internet, you can check. So for you guys, you can just visit this super simple pre-trained or transfer learning based example, right? You can just visit, and at the end you can see over here it can easily classify everything. So in this video we will be using this particular example for like transfer learning using pre-trained network example for our face emotion recognition. For this, what you need to do is that you can just visit Google again, and you can just write FER 2013 dataset, and you can just, for example, click this. And once you click over here, you can find that you have test and training data images. Make sure that you just click this one, because we do have another, if you write FER 2013. So there are two kinds of data sets. One is in the form of CSV file, the same data set but in the form of CSV file. But as we are processing the images, so it's better to use this one, right? Once you click download, so it will start downloading. You see over here it has started in the name of archive, right? So I have already downloaded, okay, for this example. Okay, so I have already downloaded this one, archive, and once you visit the archive, you will find train and test, the same data set which I have over here shown, right? This is test and train. Now one important thing I want to let you know, that once you open the example, for example, once you open this example, you will find once you run as an live editor, it will start downloading this one, right? Merge data, I hope it is visible, torch and all of them, right? So it will start downloading, but in our case we do not need to use this data set, rather we are just using the data set we have just downloaded, such as training this data set, right? So the most important thing is that you should not make any changes to example. It will also download these 3 files as well: create L graph using connections, find layers to replace, and freeze weights. These are the 3 most important files that we will be needing for this tutorial. So all you need is to just copy these 3 files from this user and documents MATLAB example wherever you have running. So by default this one would be nnet. So by default this would be the folder in which it will run the example. Once you just run it, and you will find these kind of file over here. Right now I have just cut them and just paste over here in my new folder. Okay, so let me copy my new folder. Why I'm doing it? Because I do not want to make any kind of changes. Let me go to the rather than live editor, let me create a new script, and then let me change the path according to my new path where I'm going to work. So what I did, you see these are the 3 functions file, right? I have just downloaded them from the example folder. So this is my plain code. What I did is I have just copied all of command rather than unzipping. I have just used this folder, this command. This is the command. So initially it was merge, the folder name was merge something, but I have just changed, this, and rest of all lines I have just copied and pasted over here. Okay, so all of these lines are just copied and pasted in the editor, right? So now that I have done all of them, it's super simple, good to go, right? But one very important thing is that over here you can see net is equal to AlexNet. I could have MobileNet, GoogleNet. I have tried all of them. How to install them? If you just run it, it will give you an error, and then it will pop up that how to install. But before doing it, we can also let you know that if you go to home and environment section, if I click manage add-ons, I want to see what I have installed so far. So I have installed image acquisition toolbox for my camera. Second thing you see over here, deep learning toolbox I have already installed, like AlexNet I have already installed, right? So in case you want to install, then you have to add on rather than clicking manage, you get add-ons. And for the first time, definitely you might have not installed this AlexNet or any other deep learning pre-trained network you might need to install. So what if I write AlexNet, if I search AlexNet, you see over here I have already installed this AlexNet. So in your case it might not be installed, so you can just install, or any of other like GoogleNet or ResNet or any of them you want to install, you can just install. So these are the steps. What I did, first step, I copied all of the commands I can run. So I recommend you that for the first time you just run this command and just find the, for example, in the help I want to show you, just run the live script and you will good to go, and everything will happen automatically, and you will reach over here for classification of these new networks. So they have used AlexNet or GoogleNet or any other net for classification of this torch and cube and screwdriver, but we are using the same example for our face emotion recognition dataset, right? Okay, so I have copied all of them, and let me give you for example, if I set archive inside, if I go and then if I go inside, let me copy train over here, and over here it will definitely let me run it. So I am predicting that it will give me an error because my folder my code is somewhere else, so I just add to path. So definitely it will give me error. Why it is so? Because for the example, if I see the example, although you see over here it has started creating the AlexNet, but it will throw error. You see it has thrown an error. Why? Because as I was expecting, this requires 227 into 227, like 224 into 224 into 3. This is the one it needs, right? So in our case, if we visit the folder, the data set, as we have already discussed in the beginning, that these are 48 into 48. You see over here, these are 48 into 48. So the size is 48 into 48. So what we need to do is that we have to resize them all, because AlexNet is trained on 2 to 7 into 2 to 7, as we already discussed in the beginning, right? So let me write a new code, and okay, let me write a new code, and okay, over here I should write, so clc close all, clear all. Okay, so let me create any directory, and I would say modified, any name you can give to the folder, and then let me check what kind of images they are. So they are JPG, right? So they are JPG. So let me search, and this is my dd is my variable name, and let me search static.jpg inside the, okay, so this is the one. And then for example, for counter is equal to 1 till length of all the folders inside dd, and let me do it. And okay, so now I have read, for example, I will read all of the folders in all the folder with extension of jpg, and then I can do is image is equal to imread. I will read. So over here I will have, inside the folder I will have dd dot, for example, cntr dot name. Okay, so this would contain the name of this file, right? And let me execute. Okay, I haven't saved, so let me save it. Let me save with the name converting image sizes. Okay, so the folder I would like to give it to archive, and then for example inside train, and for example I would go to inside the angry, right? So let me just do it. So it would create the directory, the modified images. I hope so. Yes, it has created the directory with modified images. Then so it has searched all of them. It's 3995 images it has found, and let me read the image. Okay, and if I say F10 is the command, but and the img resized. Okay, this is again my variable is equal to im resize. Let me resize all of these images into what? I need to do it into 227 into 227, right? So as we know that these are gray images, right? Only 48 into 48, not the 48 into 3. So these are actually gray images, but we know that AlexNet required 227 into 227 into 3. AlexNet required 227 into 227 into 3 because it requires RGB image. So if I just say F10, so it would be here. Let me quit the debug. So if I say figure, if I do it like this, so it has contained this image, but it is 48 into 48 in size, right? So I need to resize it, and then after resizing it, let me copy the code. So after resizing it, I can just do it. What I can do is I'm just concatenating using cat command and in converting it to 227 into 227. So this is what I'm doing over here, right? So I'm just converting it into this because AlexNet required. So previously it was like this, and then after concatenating, now it is RGB, and now I can easily write it. Now I can easily write imwrite is the command to write them, and then with the same name inside the modified folder. You see over here right now modified folder is empty, but once I run this whole code, okay, so I hope it would just Maybe. Okay, I'm resized. Spelling was wrong. Sorry for that. And let me run this code. And let me stop. Control C is the command to stop, because let me have some semicolon, so that although it was working fine, but it would take more time. So once I do, now I would, when I go to my folder, this modified images, so as because of the RAM, you see inside the modified images, it is with the same name, it is being pop up. So it's done. So you see over here, previously as in the discuss folder, there is no modified folder, only the angry. In case of the angry, it's there. The modified images is the folder. So you see these are now 227 into 227, and they are RGB. How to check RGB? If I just right click and go to properties, in details, you see over here the bit depth is 8. Okay, however, in case of 3 channels, go to and details, I will check these are 24 bit, right? Bit depth is 24, and 227 into 227, it shows that 8 into 8 into 8, right? 8 3s are 24. So that is why they are RGB. So now our requirement is complete. What we need to do is just cut this, and for example, you have to run this code in the angry you have already run, then go to disgust and just run this code again to convert all of them, and stepwise you should convert all of them. Okay, let's do it for the fair again, and so on. To save time, I have done some inside my practice. I've already done this final data set in which I have converted all of them. So let me copy this data set I have already done during the practice. So I just show you how to do it, and outside let me copy. I was saving time, but it's taking time. That's okay. I hope it will happen soon. So what you need to do is just repeat all of them, all the steps, just click and just do it for everyone, right? Similarly, so what it did is to what it needs to do is to convert all of them from 48 into 48 into 227 into 227 actually. Okay, it's 33%. Actually, usually when I follow my tutorial, I do it at once. That is why you might have seen a lot of like I do not even use the scripts, honestly speaking. So as I do not have much time usually, so that is why I just do it directly, and I do not actually use some scripts. And definitely in the future I would like to do it, because sometimes it wastes your time. So I really apologize for that. But usually I really do it in a one go. So I never thought that the copying would take time. But anyways, sorry for that. So I'm just doing it for you guys so that I will create. So what I did is I will just go into train folder, for example, and I will just run my code where I just wrote the code in front of you, and all you need is to just convert all of them into 48 into 48. Okay, sorry, 27 into 27. Okay, done. Okay, so now as it's done, so let me go to the codes again, and you see over here final data sets. So over here I will rename F2, and then at the okay, so this is very important final data set. Now I can come up, as you see when previously I run this code, it gave me an error for 227 into 227, but this time I hope it will not give me an error. So now let me change the final data set. Okay, so inside final dataset all of them exist, and all of them are, for example, for 227 into 227 into 3. Okay, now I hope this time it would run and it will not give any error. Let me run this code now, and I hope this time it would run. Okay, so it has just shown us how AlexNet look like, how many layers of the AlexNet do exist. Okay, now it is normalizing all the input. So this kind of thing, why I'm doing it, because I'm doing it as you see for the folder I have just created in front of you, and I didn't have anything at all, right? So this is the one I have just done in for you guys, right? So that you can just follow stepwise and you can just do it everything. by yourself. So after some time, so after 21 minutes so far, it has achieved, after one epoch, it has achieved around 45 or for example 48% of accuracy. So now it's definitely, it will go for total 20 epochs, and the second epoch is going on right now, and our hardware resources is CPU, right? So that is why it is taking too much time. So almost around 20 minutes for one epoch, and it has to complete 20 epochs. So around 20 minutes, so 20 to 20, almost 400 minutes it would take for the training. So all you need is to just start training, and you can just keep it running for the whole training period. So definitely it is kind of exhausting, but once you run the training, you can just do some other work and in parallel, and you can just minimize it and keep it going on. Okay, after training for 354 minutes, I just left my computer on for the whole night. So the MATLAB has just completed its training in 354 minutes, and the validation accuracy till end of the time is 64% almost, right? So now it is AlexNet, it has been trained. So the best thing that you do not want to waste your whole day again, right? So the best thing is that you better just save your results, so with any name. So for example, let me save with AlexNet dot mat, okay, or you can say AlexNet, and you can just say 64.03, anything you can name it, right, with any name, and you just run. I will only run this code by selecting and press F9. If you just press F9, so it will only execute this. Okay, so now that I have trained my network, the deep learning architecture on my final dataset, let's check either it can work well on other things and or not. So I was about to save a surprise image. I just search on Google and I just select this image, okay, and I just saved this image, surprised man.jpg. okay, so let me save the name and let me create another MATLAB in which I can say CLC. I'm not clearing right now, it's better that close all. And now let me img is equal to read this image. For example, let me read that it was JPG, right? So let me run it. So definitely it will sing. So I will say test my images. Okay, I will just okay, I should not do like this. Okay, let's run it again and test my image, and when I say I'm show into img, okay, so it will just show me. Okay, now that I have read the image, that how it looks. So for example, okay, so before for example, if you can clear over here as well. So after clearing, you can later, or like you can load your for example, before, and you don't need to load right now, but you can also load if you want, right? For example, this one, so you can just load your all data which you have trained. So initially definitely you have already saved this, so you can just load it, okay, later. But for now I'm not doing it because I have already loaded. For you guys, if you just close your computer and later you need to load, then you can just do it, right? So okay, once you do it, the most important thing is that our most of the image data set were based on faces, right? For example, if I check the angry face, so these are mostly the faces, and the background is too much less, right? So background is not here, so it's better to detect the face first, right? So let me detect the face, and I will just copy a few lines from my notes just to save the time. So this is a face detector, this is a variable name, name, and as I told you that I have already installed computer vision toolbox. So vision dot, if you just write for example vision dot, when you just press the tab, so you see, so when you press the tab you should have to wait. For example, you see a lot of other all computer vision things just come up. So this one I have already selected, the cascade object. What it does, it just select the faces. Okay, so then after selecting the face, actually it is a descriptor. Okay, once it has selected, and then we can say step face detector, like this face detector and this image I will pass through it. And okay, let me do it again, let me run it again. So it has detected the face, but okay, it has detected the face, but I'm just doing it again, img and img. You see, that is why both of them are image. I need to just show you this, but before showing you this, the good thing is that let me comment this. What if this if any face not detected, right? This is also the possibility. So let me check that either if my boxes are not empty, if I have actually found a box in it, so then I can run this code, and then the rectangle is the command, and this align width I have set 5 and color with the blue, and I'm cropping as well. So now after doing it, so for example, okay, so let me run it again. So you see over here now it has blue color with line width 5, and it has just detected the face, right? So now after detecting the face, I am also cropping it. So now face cropped has my detected face. Okay, one very important thing is that as I told you before, if I check the face cropped length or size, let me check the size of the face crop. So you see 174 into 174, and it could be any, right? Sometimes the face would be small, sometimes the face would be bigger. So the best thing is that I should convert into 227. Why? Because it is the AlexNet requirement, right? So okay, once I just convert it, if I check my example, so over here there was some prediction going on, right? So I can just copy it from my example, the plain code. I have just copied from the example, the pre-trained example. I can just copy paste over here, and as I haven't changed the name, you see over here net is there. So the name of the net you can change. If you remember when we were writing over here, you see this, when I was training, I assign the name it as a net. So you can assign any name according to your requirement. So now I have for example this one, so net is same, and this should be my this cropped image of the face. So what I need to do is I need to check. So let me run again. So okay, it has done, but I haven't. For example, if I check what's going on over here, so you see my prediction is surprise. So it is working perfectly. It can classify very easily. As in front of you, I just downloaded this from internet and I checked. Although this was not a part of my dataset was something else, and I just downloaded, and it's perfectly working. And you can try any other examples as well. Now that I have done, so actually if you check, this is categorical something. So I want to plot it. So the code to plot on the, okay, so this is a piece of code I have written so far. Nominal y prediction, and then prediction cell to, because it was categorical, so I'm just changing it. And the position of the, okay, what I'm doing here, let me show you. If I run code, and then I will show you what's going on. Okay, I think it's not be, yeah, it's figured, it's okay. So you see over here what I'm going to do right now. I have just till this point, okay, let me show you. Till this point I have rectangle, I just plot rectangle, and then I just cropped and just check either it is surprised. So after being surprised, I just check this prediction, okay, and then I change into str from to string, and then after changing it into string, what I did is that I'm just position is 0 0, so that is why the starting position is 0 0. You can select any of them, but I just make this position as initial one. And this is the size of the insert text. You can just search in the help, and you can just the box opacity, you can change opacity. And for example, if you need transparent or not, so it's up to you. I've selected 0.4, and you can for example any like font size 18 and any other things you can just do. So whatever would be the prediction, it will just write over here, right? So let me search again on internet about, for example, happy boy. Okay, so this one, let's select this one. I usually select this in my tutorial. So this is again happy boy. I just saved with the name of happy boy. So I will just copy this and then I will just paste over here. I hope it would work perfectly. So you see over here it is working perfectly and it shows that it is happy. Okay, so now we are ready for our live webcam demo. So if you have webcam, just install. I'm also going to install my webcam, and then we are going to start our coding for the live webcam demo. Okay, now that I have set my webcam, and then we can again, okay, so what we can do is we can just for example load first, and I'm not using it again, the loading one, but you can use it as well. If it depends upon you, either you have deleted your RAM or not, either you have restarted your computer or not. Okay, so once I do have this, let me start the webcam coding. So the webcam setting could be like this: delete MAQ, and so for example MAQ image acquisition toolbox I have already installed. So you see over here, if I write like this, okay, so it is just deleting all MAQ fine, and I can just for example this is the command image acquisition info as well. So you see over here I've already installed this adapter or drivers for my MATLAB for accessing my webcam. So I'm just in the start, I'm deleting, maybe this my webcam has been accessed by someone else, so that is why I'm just clearing my settings. And then I'm just, as I told you, that Win Video is the one. I'm using Win Video. You can have multiple adapters if you have multiple webcams as well, right? So I'm just using a computer having webcam of Logitech, so that is why I'm just using this one. Otherwise sometimes you use laptop, so in that case you can have multiple webcams. So you can just select the ID, and then trigger configuration is manual. Why? Because in the coding I will do it. So okay, after these settings, and one important setting is this one, for example. Okay, so view the default color space used for data. Okay, so I'm just doing it. These are my settings. Okay, and again you can just copy paste this code. Okay, so str compare color space RGB. So I'm making sure that everything is in RGB. Now after setting my this video object vid object, this can be any name you want to select, so I can just start. So after this my camera would be started, and then what I can do, I can also initialize my face detector object with that I already did over here, face detector. Okay, you can just copy from here, and then once you already done, so there are multiple things, multiple options. One thing you can do is for example you can just while one you can do, but I'm just taking the, I have just copied all the, okay, so what I'm doing after this face detector, I'm using some 600 till 600 second you can say, or I'm just having some loop till 600, and then I'm doing it trigger. Okay, I'm just triggering. Why? Because I've selected trigger into vid, and after each trigger, just a kind of, you can say that I'm just resetting my webcam, and then I'm just doing get data frame by frame, and after that I'm just showing the image, and then I'm just again, as I have already initialize my face detector like this. Sorry, over here I've already initialized my face detector, so I'm just detect the face, and after that I'm checking that I'm making sure that there are boxes and faces have been detected. Okay, if the face is detected, then, because if you do not do this command, then rectangle might fail, right? Because you want to draw a rectangle on box. If the box do not exist, how can rectangle command would work? So it will give an empty and it will throw an error, right? So similarly, again similar code I have just copied from here, right? Face cropped and all the code I have just copied over here. The the only important thing I did is that I'm using this webcam now. Previously what I was doing, previously I was just reading the image. Right now I'm not reading the image, however I'm just get that I'm doing, right? Let me reduce the size over here for you so that you can view it all. Okay, and then crop the face and convert into 227 to 227. So now it depends upon you. If you are using 228, you can also use 228 into 228. Okay, and yeah, and then for which 224 into 224, sorry, for 224 into 224 is for mobile net and all other AlexNet and Google net, right? Previously I have shown you. See, if net is AlexNet, then 227 into 227. Otherwise for all of them it is 2 to for this it is 227 into 227. Let me write, it's 227 into 227 for AlexNet, and for all of them, rest of them, it is 224 into 224. Okay, so now that I have let me save webcam demo. Okay, any name you can give, and let me run it. So I hope it would work. Okay, so it is showing me a little bit errors as well because my view might not be correct. Okay, so let me be happy. So most of the time it's showing happy. Similar, for example, angry, surprise, it is showing surprise, and sometimes it's fear as well. So definitely you can just set up, I just install my laptop, and it has definitely some issues as well, for example, as I'm talking as well, but definitely for you guys I hope really it would definitely work. And for example, if I'm good angry, you see it's continuously saying angry, right? So yeah, there are errors because it is 64% accurate, not the 100% or 99%, but you can improve your accuracy. So if I surprise, you see it is, I hope it is showing me surprise, but surprise and angry is, I think, confused, and sometimes because I'm showing my teeth, so that is why it is sometimes showing the happy. So the best thing to for being happy is to show your teeth. So it detects that you're happy. So this is a trick I'm telling you. So okay, that's all from for today, and thank you so much for everything, and thank you so much for watching, and keep supporting us like this.